Hi everyone, I'm Micaiah D, and this is my lab report, Charge Tape for Physics 2212. So a little background on this lab, we were expected to create a net charge on pieces of Scotch tape and measure the excess charge on one piece of tape by observing different interactions. The goals of this lab consisted of gaining a better understanding of the electric force, also known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. Some physics principles to keep in mind are objects cannot exert a force on themselves, like charges repel, opposites attract. Here are my results. I identified the sign of the charge of the Scotch tape to be positive. When I calculated the charge of the tape, I got 1.374 e to the negative 8 coulombs, which was within the same magnitude as the textbook example. And I created a virtual representation of the experiment by adding functions to calculate charge and using old functions from previous labs to help find the forces. Here are my measurements that I took. I recorded the initial height of tape B before I introduced tape A, and when I introduced tape A, the repulsion between the tapes caused the distance to increase between them. Some observations I made: the charged tape was attracted to the negatively charged pin, which meant the sign of the tape was positive. The net force on tape B is 0. Repulsion between the pieces of tape caused B to flow. So notice that the electric force and gravitational force are equal in magnitude but opposite in direction, which meant that the net force on the tape is 0. And I use this knowledge to help me calculate the charge by setting them equal to each other and isolating Q, and using my measurements to help find the charge. And I ignored air resistance, treated the tape as a point particle with charge concentrated at the center, and notice that the charge is evenly distributed among the surface of the tapes. Here are ratios. The number of electrons on tape B is the resultant charge, which we found, divided by the electron charge. The number of atoms on the sticky side of tape is the tape length, which we measured, divided by the atom's diameter, which was provided for the lab. And the ratio of electrons to atoms is the number of electrons divided by the number of atoms, which we found. Here is my coding. You can click on this link. It'll take you to my computational model. You can zoom in and notice that the orange arrow is the electric force and the green arrow is the gravitational force, which are equal in magnitude but opposite in direction. And you can hit edit this program and it'll show you the code behind how I got my computational model. So here are some final questions. What if electrons had a positive charge and protons had negative charge? Well, the sign of the tape would change for my experiment, but everything else would be relatively the same since charges are switched for everything. So charged objects still attract neutral objects. The U-tapes would still continue to repel each other, so the laws of physics are not broken. Why is it important to handle the charged tapes as little as possible? Well, I personally faced this problem. When I kept touching the tape, I had to constantly recharge it because the transfer of charges through contact caused the tape to lose charge, and interactions didn't happen as expected. It no longer repelled another U-tape, and it wasn't attracted to my hand or other objects, such as books. In conclusion, the lab helped demonstrate the transfer of charge between everyday objects, as well as visualizing Coulomb's law and Newton's third law, the reciprocity of forces. I was successful in calculating excess charges. Thank you for watching, and I'll come back with more physics fun.